Okay, so let's first recall that R is the sample correlation. And this is used to estimate rho, which is the population correlation. Okay, so we're going to talk about how to do confidence intervals and hypothesis testing for rho. Okay, so we have to use this the fact that the quantity W, which is defined to be 1/2 ln of 1 plus R over 1 minus R, is roughly normally distributed. And the mean mu W is equal to 1/2 ln of 1 plus rho over 1 minus rho. And the standard deviation, sigma W, is 1 over square root of n minus 3. Okay, so we're going to need this later. And first, if you look at this, this is how we write mu W in terms of rho. So if we calculate the inverse of this, we can express rho in terms of mu W, which we'll need later. So you can do it on your own. So mu is equal to e to the 2 mu W, sorry, 1 second, e to the 2 mu W minus 1 over e to the 2 mu W plus 1. So we need that fact later. All right, so let's use this in an example. So let's consider an example with a sample size 19. And the sample correlation is 0.6. So let's calculate all the necessary quantities. So W is equal to this. We can calculate W. W is 1/2 ln of 1 plus 0.6 over 1 minus 0.6. So W is roughly equal to 0.693. And we can also calculate the standard deviation of W. So sigma W is 1 over the square root of n minus 3, which is 19 minus 3. This is 1 over the square root of 16, which is 1 over 4. So that's 0.25. So using these two facts and the fact that W is normally distributed, we can calculate a 95% confidence interval for mu W. So because it's normally distributed, so the center of the confidence interval is 0.693 and plus minus 95% normal, so it's 1.96 times 0.25. So we calculate this. This thing has lower bound is 0.203, upper bound is 1.183. So the 95% confidence interval for mu W is between 1.183 and 0.203. So that's the confidence interval for mu W, but we want a confidence interval for rho instead. So now it's time to use the purple relation we just derived. So all you need to do is to plug in those upper bound and lower bound into that fraction, and then we get the 95% confidence interval from the rho. So the upper bound for rho is going to be e to the 2 times 1.183 minus 1 over e to the 2 times 1.183 plus 1. And the lower bound is going to be e to the 2 times 0.203 minus 1 over e to the 2 times 0.203 plus 1. So if you do the calculation using your calculator, the confidence interval is going to be rho between 0.8284 and the 0.2. So this is your final answer. Right, so that's how we calculate confidence intervals for rho. And we can use the similar principle to do hypothesis testing for rho. So let's erase the bottom right part. So let's consider the hypothesis testing. H0 is rho is less than or equal to 0.3, and H1 is rho greater than 0.3. So to do the hypothesis testing, first we deal with the null distribution. So this is the null hypothesis. So the null distribution, under the null distribution, mu W is equal to 1/2 times ln of 1 plus 0.3 over 1 minus 0.3. Using calculator, that's equal to 0.3095. So the null distribution is the normal distribution with mean 0.3095, and the standard deviation we calculated before is 0.25. So the mean is 0.3095, and standard deviation is 0.25. The observed value is 0.693, so it's about here. W is 0.693, so the z-score is 0.693 minus 0.25. No, sorry, minus 693. Oops. Z-score is 0.693 minus 0.3095 over 0.25. This is equal to 1.53. Okay, so that's the z-score, and then if you look up the z-table, you can find out the p-value is 0.0635, which is greater than 0.05. So we cannot conclude that rho is greater than 0.3 because the p-value is not less than 0.05. Right. So one last thing for this section. So in a special case where the null hypothesis is rho equal to 0, rho less than equal to 0, or rho greater than equal to 0, we can use the test statistic u equals to r times square root of n minus 2 over square root of 1 minus r squared. And this test statistic has student's t-distribution with degree of freedom n minus 2. So we can just use the t-table to find the p-value or the range of p-value. So let's do an example here. Let's use the same example as before. So the sample size is 19, and the sample correlation is 0.6. Then you can just calculate u directly. U is equal to 0.6 times square root of 19 minus 2 over square root of 1 minus 0.6 squared. This is equal to 3.092. So if we want to calculate the p-value of the hypothesis testing, the null hypothesis is rho less than or equal to 0 versus h1 is rho greater than 0. Then we look at the t-table. So look at the t-table with degree of freedom is n minus 2, so it's 19 minus 2 is 17. So we look at the t-table, row 17, and look for the value 3.092. We get that p is between 0.005 and 0.001. In particular, p is less than 0.05, so we can reject h naught at the 5% level and conclude that rho is greater than 0. Alright, so that's it for section 7.1.